Hello everyone. I'm creating a set of technical videos on data science and machine learning, and my hope is that this set of videos is going to help you with your journey in becoming a data scientist. I'm going to start from the basics, and then gradually over the next few videos I'll focus on more advanced concepts in data science and machine learning. I'm running my PowerShell. I'm on a Windows machine, so I'm going to use PowerShell as my terminal. One design principle that I'm going to follow, and I encourage you to do the same thing, is to keep everything about your different projects, separate. So you want to create a separate physical environment, an isolated environment for your project. So for this particular project, I'm going to create a directory. I'm going to call it video lessons. You can give it your project's name, and so basically this is creating a separate folder, and I'm gonna place all my model files, documentation, everything that I create and is related to this particular project. I'm gonna place it in the same folder just to make things easier. I might end up working on multiple projects at the same time, so it helps to have some physical separation between your projects. So I'm going to move to this folder, and as we can see, there is nothing in it. So the next thing I'm going to have to do is to make sure that I already have Python installed on my system. And there's different ways to check to make sure you have Python. The simplest way is to just type Python. Python is an executable file, and so if you run Python, your system should be able to find the Python executable, and it's going to run the Python interpreter. And so there you go, we have the Python interpreter, and I can just give it a simple command like 1 + 1, and I get back the answer. So I'm going to quit my Python environment. Now I know I have Python installed. A second way to make sure you have Python installed on your machine is to use this get command tool in your PowerShell. And so you say get command Python, and there you go. It finds the executable version of the Python. It's telling you we have Python version 3.9 installed in this machine, and this is the location in the system, in the file system, that has the Python installation. So now I know I have a system-wide Python environment on this Windows machine. So the next thing I'm gonna need to do is to create a virtual environment for my machine learning project. I'm starting out on a new project, and it's a good practice to create not only a separate physical environment for your project, which is what we just did by creating this folder, and we're planning to use this folder to keep everything that we create and is related to this project inside this folder, but also create some virtual separation. What do I mean by virtual separation or virtual environment? So Python programs, and in particular machine learning programs, depend on packages, libraries that are developed by the community, by other people. And different projects might depend on different versions of these libraries. And so one thing that we want to do is to make sure that we have a separate copy of those packages and libraries with our program. Again, because different projects might need different versions of the same libraries. And so when I created that directory for my project, the plan was to put everything that I create for this project, including my models and my documentation, inside this folder to create that physical separation, but kind of following on the same principle, I also want to create this virtual kind of separation. The idea being that I know I have a central version of Python. We just saw that I have a central system-wide version of Python 3.9 installed on my machine, and so that Python that I have comes with some packages, and over time when I install packages, all those packages add up to my system-wide Python. But for this particular project, as a best practice, I want to have my own local version of the libraries that I'm using, because um, over time, these system-wide package repositories, if you will, are becoming larger and larger. If every time I work on a project, I use the central version or the system-wide version of the libraries, these libraries increase over time as I work on different projects, and they get really big, and you end up in a situation where you have hundreds of libraries in your Python environment. And now think about shipping your model. You're done with your model development, and you want to deploy your model or deliver your model to someone else that's going to be the user of your model. And now you kind of are in trouble, because uh, you really don't know which packages you used. If you ship your entire environment, this is hundreds of packages that your project is not using. Those were packages that were used by other projects, but because all these projects were using the system-wide version of the Python, everything got installed in that central location. And so I really like this idea of absolute separation, both physical and virtual separation. So this is over these lectures or video lessons, I'll talk about uh, different design principles. And this is our first design principle: keep everything related to a project separate, both physically and virtually. With physical separation, you basically separate the artifacts that you create, your documentation, your project code, your Python files, your Jupyter Notebook files, everything that you create for your Python machine learning model. With virtual separation, you are basically separating yourself from that system-wide Python installation and packages, and basically you create your own local version of packages and libraries. And so your project becomes a self-contained project, and it becomes easy to ship and deploy your model. It becomes kind of easy to work with your project. You know, installing new packages is not gonna unintentionally break some other code from other projects, because you're not gonna have to deal with issues related to the um, conflicts in different versions of your packages. Different projects might need to use different versions of the same library, and so when you upgrade a library to use with your new project, you might unintentionally make some other model that used to work not work anymore, because that previous model might be dependent on the previous version of that same library. And so when all changes are happening in a central location, that's where you might end up having issues. And so here is our first principle: keep everything separate virtually and physically. So how do I've already created a folder that or directory that I'm going to use, and that gives me uh, some physical separation. But how do I create that virtual kind of separation that I just talked about? How do I create a virtual environment for my Python environment, for my new project? And so what I'm going to do, I'm going to run Python -m. Uh, I'm going to run the venv, or virtual environment module, and we have to give our virtual environment a name, and I'm gonna just call it venv, standing for virtual environment. If I run this command, I'm basically telling Python, create a virtual environment for me, call it venv, and place it inside my the folder that I just created. So this is going to take a few seconds. When it comes back, we should have a folder called venv inside our project folder. Let's take a look at it. As you can see, I have this venv folder, and this is my virtual environment. So basically, this is the uh, environment that I'm going to use to install all packages that I'm going to need to use with my project. And so uh, we need to activate this environment. Uh, we need to tell the system that moving forward, when I'm uh, running commands, when I'm installing new packages, I don't want to change anything in the central environment, in the system-wide Python. Uh, when I'm installing packages, install those packages inside this local virtual environment that I just created. And so I have to activate the environment. That's my way of telling the system that moving forward, this is the environment that I want to use. And so uh, so venv is the folder that was created. Inside this folder, there's going to be a folder or directory called scripts. And inside scripts, you are going to have an executable script called activate. And if you run it, this is going to activate your virtual environment. Now my virtual environment is activated, and the way I know I'm on this particular virtual environment is if you look at the first few characters in my prompt, you see the virtual environment name in parentheses. So before I didn't have this, now I have this highlighted, and so it reads VM. What this means is that all these commands that I'm running in my command line, now these commands are going to run within this virtual environment. So for example, if I install a new package, it's going to go to this virtual environment and not the system-wide environment. So you might be wondering what happens when we activate an environment. What does it really mean to activate an environment, a virtual environment? And so the way it works is that uh, if you all this is doing behind the scene is when you run a command in your terminal, what the system is doing, it's going to look through a number of paths or locations or places in your system to find the executable file or the command you're issuing. So for example, when I say Python, or when I say pip, which is the Python package installer, what the system is going to do, it's going to have to file, or it's going to have to locate the file, the executable file for that command, and then run it. But what's the order in which the system is searching to find this file? If you want to see a list of your environment variables, you can run directory env colon, and this is going to give you a list of your environment variables. And you can go through the list, but if you look at this one here, path, if you notice this is where executable files are running from. And as you can see, the folder or directory that I activated, the virtual environment that I activated under video lessons VM scripts, this is now at the beginning of the queue. This is at the beginning of the sequence. So what this means is that the system is gonna look for this directory, scripts directory, and it's gonna look for executable files here before it moves on to other locations. And as you can see, the second location is my system-wide Python installation, which is this Python 3.9 scripts folder. And if you look inside this folder, you can see that your Python is coming from here, so you should have a Python executable file here. Your pip Python package installer is going to be here. Your executables are going to be here. So basically, this is what happens when you activate a virtual environment. The path to that particular isolated environment becomes the first path here in this path environment variable, and so when you run executable commands, uh, this is where the system is gonna look at to find those commands, and not the system-wide uh, kind of location. And so just to see how it changes, by the way, you can also do directory environment path if you just want to see the value for just one particular environment variable, and you can see here still it's the same. Now what I want to do is to show you what's going to happen if I deactivate this environment. So I can say deactivate, and as you can see my command prompt changed. Now I don't have VM in front of my command prompt, which means the VM environment that I created is not the active environment anymore. And so if I run directory env and then look at the value for the path environment variable, as you can see now it's back to the Python installation in my C drive. So basically this is telling me if you moving forward, if you run commands to install packages or run Python, the Python that you're running is going to come from this directory. The packages that you're installing are going to go into this system-wide kind of environment, and not the environment that you created for your package. So basically that's how activating and deactivating environments work. By activating environments, you are basically telling the system that you need, moving forward, kind of use my isolated environment, install things in my own environment, and don't change things in the system-wide environment. So I want to activate my environment, so I'm gonna run this activate command one more time. Now my environment is active again, and so the next thing I'm gonna do is to install a development environment. I'll need to write Python code, and so there's different tools that you can use to develop your Python code. In particular, I like Jupyter Notebook. It's a very lightweight environment to work with, and I really like simple tools like Jupyter Notebook. You can combine Python code, you can write pieces of Python code and then pieces of documentation, combine things together, and it's very handy when you are developing your proof of concepts, where you think about a problem, you convert it into a piece of code that implements your ideas, you put it in a you write a little bit of code, you put it in a Jupyter Notebook cell, you run it, you see the result, you document it, you move, and so it's a very simple environment. It's not getting in the way of me thinking about the problem and writing my code. Some of the other tools are a little bit more complicated, and so I think I really like simple tools, because I think the purpose of a tool is to help you become more efficient in what you are doing. And if the tool has so much functionality and it's so complicated to use that you're spending a significant amount of time trying to understand how to get things done inside that tool, then it's kind of defeating the purpose, because the tool is meant to help you become more efficient and not taking time that you are supposed to spend on thinking about the data science problem or thinking about your code. Now you are spending thinking about the tool. And so and again, going back to my idea of separation, I even like to have a separate version of my Jupyter Notebook editor for each project. And in a few seconds, I can have my, an environment that I can actually start using to write Python code. So what I'm going to do, I'm going to use the Python package installer, the pip, to install this Jupyter Notebook. So I'm gonna say pip install, and then the package name. In this case, it's the Jupyter Lab. So this will take a few minutes to run. Uh, it's working on it, and in a few minutes, uh, I should have a development environment that I can use to actually start writing Python code. All right, so now this is done. All right, so we just successfully installed the Jupyter Lab environment. So to use it, we're gonna say Jupyter space lab, and this is gonna run the Jupyter Lab server, and it's also gonna open your browser, and it's gonna run the Jupyter Lab environment. So, and as you can see, I have my web-based development environment here, and I can actually start working with this environment. So I can create a Python notebook, and this being our first program, I'm just gonna simply print a message here, and there you go. This is our first Python program, and we managed to successfully set up a running Python environment. Thank you for watching this video, and I hope it was helpful, and I'm looking forward to be your host in the next video.